We're going to be showing you today a automatic eyelet and terminal insertion machine. This machine automatically feeds and inserts eyelets with our standard model WW722 eyeletting head. This eyeletting head is a standard product, has been used on a number of applications inserting eyelets in very high volume. Today we're looking at a machine that's inserting one eyelet at a time. We have built for this same type of application eyeletting heads that insert two at a time, which is more applicable to your application at Rockwell. Along with eyelet insertion, we're inserting terminals that are punched out on a continuous reel. Terminals are punched by a Lord's press. The Lord's press feeds in bare stock or raw stock, punches the terminals out. The terminals are then fed underneath our machine, where we index one terminal, cut it off, and then present it to the bottom side of the insertion area, where we then eyelet through the terminal and fasten it to the work. The Lord's press is quite loud. When evaluating this application, you may want to consider purchasing a sound enclosure. One thing you may want to note about rate, this application required an extremely tight setting, and as a result we used a very heavy-duty air cylinder which slowed the machine down. Now the terminals are being fed from the Lord's press, come on reel as you can see, and we sense the tension in the reel and tell the Lord's press when we need terminals, and it turns itself on and on automatically as required. Basically we just sense electrical contact on either the top or bottom side of this plate, and when it's at the bottom we know we have enough terminals, and when it's at the top we know we need more. It's very simple. As I was saying a minute ago, this machine is running significantly slower than yours would, and that's because of the large air cylinder required for this application. These people were using only one eyelet to hold the terminal to the material at this time. Therefore, the eyelet had to be extremely tightly set to keep the terminal from being able to spin, which required more air pressure, which slowed the system down. With two terminals, we're able to run a significantly faster machine because this pressure setting doesn't need to be as extraordinarily tight. I think we've quoted Rockwell 90 insertions a minute, and here we're probably running more closer to 60. I don't have a stopwatch on, so I'm estimating. Now we also have the ability on this particular unit to rotate the terminal in any orientation required. As you can see here, we just moved 90 degrees. And then 90 again, actually 180, excuse me. The XY table, insertion head, are all controlled by our own programmable logic controller, which talks to the controller provided by Lord's press. Cambridge Automatic does write all our own custom software. This is the bottom side of the insertion head where we in-feed the terminal. We feed it in, again cut one off, place it into a nest, then bring it up to the work area and rotate it as required in this application. The machine is entirely pneumatic controlled. As you can see, we have an awful lot of stroke on the lower die assembly. I think 6 inches, which also has an effect on rate. That is also going to be the same for your machine. When we feed the contacts on the bottom side of the circuit board, we will need to raise them up to the circuit board, and that will be about 6 inches of rate. Excuse me, 6 inches of travel, which will affect your rate. This is just the indexing and placement tooling cycling. You can see there's no work there. I just took the Mylar piece off so that you could see it. The terminals are kind of bouncing around a little bit. I'm not sure if that was a wise thing to do, but I did videotape this quite a while ago. You can see we index the work in, cut it off, and drive it up to the insertion area. That main shaft also rotates. It's another view of the terminal cutoff and index mechanism.